Hey, Jody here. Thanks for watching another video from weldingtipsandtricks.com. We're TIG welding stainless today. My friend Roy's previous employer was about to throw a box of these short coped pieces of stainless into the scrap, and he asked me if I wanted them, and I said sure. So I've got them now, and I thought they would make an interesting video. Let's just talk about several different things. They're roughly 120 wall thickness, slightly under 120, a little bit less than 3 millimeters. It's common to have a real sharp edge out here on this end, whether it was cut with a hole saw or however, and it's best to knock that down a little bit. It's hard to get a decent cross-section thickness on a knife edge, so it's best to knock a little flat spot on it where you can get a nice little fusion tack in there and then also a little bit of penetration without having a crowned up weld to do it. One of the handiest things I purchased recently is this fixture plate from my friend Roy Crumrine. So I'm going to use it to kind of lock it down before I get the first tack on it. You've seen me weld several things with this fixture plate. It's super handy for small parts. I'm going to give my filler rod a little quick wipe down with some alcohol here before I get started. Always a good practice. Another good practice is using a gas lens setup. Now my go-to setup is usually a number 8 stubby gas lens on a 17 air-cooled torch if I'm using air-cooled. This is a Jazzy 10. It's a ceramic Furic cup, and it's going to give me a little bit extra gas shielding today. The cool thing about it is it screws right on the stubby gas lens kit without having to have an additional adapter. If you've got a 9 or a 20 style, your gas lens is going to look something like this, and it'll screw right on there as well without any adapters. But if you want to get started using one, the cheapest way is to go with the adapter kit like this. Pull the O-ring off, set that up, boom, ready to go. You can use a nice long stick out. Good 5/8, even 3/4, no problem. 20 CFH, really I've used the same gas flow as I use with the number 8 on this 10 cup. When I'm tack welding stainless like this, I like to get a good quick burst tack. I've got the machine set to 120 amps. I'm going full pedal. I'm getting the rod in there really quickly. I'm getting a dab or two, and then I'm getting off of the pedal. And that makes for a nice, small, clean tack, and I don't put a lot of heat into the part. I want nice, clean, shiny, small tacks. That's going to help everything go better when I weld over those things or if I start on them. So really good gas shielding, making sure the metal is clean and free from adhesives, tapes, residues, anything like that. And holding my post flow for just a count. Getting that puddle started, getting a little bit of rod dabbed in there, and then holding the post flow. Nice, shiny, bright tacks. Makes everything go a lot better. Now, I like to take a few dry runs. I sound like a broken record when I say that because I do it all the time. I just think it's really good practice. Once you get doing hundreds of parts or something like this, maybe you don't need to take any dry runs if you're welding the same thing every day. But anytime you're welding something new, never hurts to take a few dry runs. Make sure the torch is not going to get hung up on anything. Make sure you can rotate your wrist and maintain the right torch angle. And it sort of builds a little muscle memory. The Jazzy 10 is doing a really good job here. I'm holding the torch still while the post flow times out. Cool thing about a fixture plate like this, especially being aluminum, it's rigid, but it's pretty easy to spin around. Before we do any more today, I want to talk about one thing, and that is getting that puddle started quickly and getting moving. Don't let that heat build up. Try to outrun that heat. One of the characteristics of stainless is not very thermally conductive, so heat builds up really quickly. So getting that puddle started within about 2 seconds, 1 second's even better, really helps. Part of that is just really being comfortable and not getting hung up on anything. The ABCs of welding, remember, always be comfortable. And the TIG finger is going to let me be comfortable here. That thing's going to get roasty here in a minute, but my fingers are not. And they're going to slide along this polished stainless almost like it was some type of glide mechanism. I mean, it's that smooth on stainless like this. This is pretty much the same finish as would be on sanitary stainless tubing. So I'm going along here, not like crazy fast, but just as, at a good clip. I don't want the heat to build up. So not only do I want to start the puddle really quickly and get going, but I want to keep going pretty quickly. And once again, I want to hold that post flow until it times out. Let's take another look at one. When I light up, let's count how long it takes me to get moving, to dab rod in there and get moving. 1,000, 1,000, there goes the rod right in there. So I hit it at 120 amps, And then after about 3 dabs or so, I back off the pedal a little bit, probably to about 90 amps or so. I don't know, I wasn't looking at the machine. Again, trying to keep going at a pretty good clip, trying to keep the hot tip of that rod shielded with argon. That's another benefit in using a gas lens, and also in using this number 10, this Jazzy 10. It gives you a little bit more forgiveness on flipping that rod around. And if you don't have the post flow extended long enough, you can bump the pedal and get a whole nother cycle. You'll see it discolor right there. That's when the post flow timed out. You notice my red torch holder with the magnetic base there. Big thanks to Jimbo's Garage. Jimbo, thanks for sending that out. Can't stress enough the importance of taking a few dry runs unless you just do this stuff all the time. I found while I was welding this one part, I found better ways to do things. I found more comfortable ways to prop and to twist my hand and to maintain a good electrode angle as I came up while I was holding the torch steady. There is just always room for improvement. Don't know if I mentioned it already. I'm using an 045 diameter ER308L filler wire. A general rule of thumb is that using one size lower for stainless on filler metal often helps. Like if I would generally be using a 1/16 for this job on steel, using 045 works great on stainless. Now, to state the obvious, I realize this is the best possible scenario you'll ever get. Welding on a fixture plate, right on a table, right in front of you, a perfectly clean metal. I posted this video a good while back, and I put this thing up overhead like this just to show that, you know, there's some techniques that you can use where welding out of position is not that big of a deal. Not that much more difficult than welding on a bench right in front of you. You just got to figure out ways to walk around the part, ways to prop, and ways to be comfortable. All right, back to the stainless. Well, now we're going to talk about a few other things as we weld the other side. I'm going to flip it over, clamp it down again. It stayed pretty flat. For the rest of this, I'm going to switch over to a slightly larger cup. I'm going from a 10 to a 12. I'm going to bump up the argon about 4 CFH just to see if it makes any difference. I don't think it will. The Jazzy 10 is actually doing about as good as you can expect on stainless. But we'll see. We'll see if just a slightly larger cup with just a little bit more argon makes a difference, or if I've just wasted argon. And it looks a lot like it did with the Jazzy 10, so I don't think it's making much difference, but, you know, the only way to tell is to finish the weld and kind of compare it as far as discoloration goes. I was able to use a little longer stick out. I didn't really need to. I just did, just to see how it did with a good 5/8 to 3/4 inch stick out. So I sped this up just a little bit so we don't have to wait for the whole post flow. But it did pretty good, but not really any better than the Jazzy 10. So probably a little overkill going to a 12 here. But if you need a long stick out, or if you need a little bit more forgiveness, if you're shaky and the hot tip of your filler rod is flopping around and you need a little bit bigger cup to shield the hot tip there, it's kind of worth it for 4 extra CFH. Not that big a deal. I mentioned earlier, and you can see that I'm not purging this at all. No argon on the back side. It's 120 thousandths thick, almost. And I don't know of anybody, if they were making handrails, that would go to the expense and the extra time it would take and the extra aggravation to purge this out, unless it was absolutely required. And there are some jobs that mandate it, but most of them don't for structural applications like this. We'll talk about purge a little bit here in just a minute. Here's another view of the sides where I tied in and everything. That cup is doing a great job on this. And here's a little shot from the inside, just so you can see. You know, I definitely heat tinted it a little bit on the inside, but no melt through at all. Again, 120 wall, and I was welding max amperage at 120 amps, and I was only using the max amperage on the start. Well, let's talk about purging a little bit here. What happens when you do need to penetrate and you don't have any argon on the backside? You get this mess. It's called granulation, also known as sugaring. What it is severe oxidation, and it's a flaw. It's an opportunity for failure. It's an opportunity for bacteria to grow. The best way to avoid it is to purge, and the best way to purge is with a dual flow meter, so that you can have one flow meter for your torch gas, another flow meter for a purge line. And then you know exactly what your flow rate is, which you don't if you put a Y in the line and try to guess at how much your torch is getting and how much purge you're getting. And so the best way I can think of to demonstrate that is using this fixture that Adam Booth, A-Bomb 79, made for me. We did a collaboration a while back. And so by using a dual flow meter as well as this fixture, I'm going to show you what it looks like when you get a proper purge on the backside of stainless. Also, pay attention here. You're going to see how quickly I get the puddle started. Once I light up, I get a puddle started probably within 1 second there and get moving. I get rod in there and I get moving. And that's going to help a lot on stainless steel in preventing distortion, preventing heat buildup. And of course, it helps with discoloration as well. And the fixture is helping tremendously with discoloration because it's such a heat sink. Now, I did this plate in 2 steps, a little back step technique, but you can see right there I got the puddle going really quickly as well. I didn't mess around. Probably took only 1 or 2 seconds. If you find yourself taking 5 or 10 seconds, you got to work on that. All right, look at the back side here, the penetration side with the dual flow meter, purging on the back side, nice and silver. That's a sight better than that. So that's bad, that's good. So if you're interested in learning more about the dual flow meter I used or any of the other cups and things like that I use in this video, visit weldmonger.com. That's my online store. That's how I support these videos. Thanks for watching. We'll see you next time.